How big is the universe? And what lies beyond it? This is Yuri Gagarin, the very first human to travel to space, and he opened the door to our cosmic journey. This is the Hubble Space Telescope, the most powerful optical eye ever aimed into the cosmos. This is the Space Shuttle Discovery, now proudly displayed at the U.S. National Air and Space Museum. This is the International Space Station, orbiting Earth more than 66,000 times. This is the Saturn V rocket, the most powerful rocket ever built. This is Bennu, an asteroid that poses a potential threat to Earth. This is Phobos 2, Mars's smallest natural satellite. This is Dactyl, the first asteroid discovered to have its own moon. This is Vesta, the brightest asteroid visible from Earth with the naked eye. This is Ceres, the largest known object inside Neptune's orbit beyond the major planets. This is Charon I, the only moon of asteroid 10,199 Chariklo. This is Pluto, the first Kuiper Belt object discovered by humanity. This is Europa, one of the most promising places in the solar system to harbor life, aside from Earth. This is Earth's one and only natural moon, the Moon. This is Io, a moon blasted by over 400 active volcanoes. This is Mercury, the smallest planet in the solar system. This is Titan, Saturn's massive moon, also the fictional birthplace of Thanos in Marvel's Infinity War. This is Mars, the red planet that Elon Musk dreams of colonizing. This is Sirius B, currently the most massive known white dwarf star. This is Venus, the hottest planet in our solar system. This is Earth, our one and only known home for life. This is Kepler-22b, a potentially habitable Earth-like world about 600 light-years away. This is Neptune, the coldest planet in the solar system. This is Uranus, the planet that literally rolls on its side around the Sun. This is Saturn, the only planet with those magnificent rings. This is Jupiter, the largest planet in the solar system. This is the Sun, a star with an expected lifespan of about 10 billion years. This is Sirius A, the brightest star we see in our night sky. This is Pollux, a giant star in Gemini about 334 light-years from Earth. This is Sagittarius A*, the supermassive black hole at the Milky Way center. This is Arcturus, the brightest star in Boötes. This is Aldebaran, a red giant star in Taurus about 565 light-years away. This is Betelgeuse, Orion's brightest star, roughly 860 light-years from us. This is the Pistol Star, one of the most luminous stars in the Milky Way. This is Antares, a red supergiant about 4,600 light-years from Earth. This is Uy Scuti, the largest star known so far by physical size. This is the black hole in galaxy M87, the first ever imaged by humanity. This is NGC 3842, a supermassive black hole in Leo about 320 million light-years away. This is TON 618, the most massive black hole ever discovered. This is the Cat's Eye Nebula, one of the most structurally complex planetary nebulae. This is the Barnard Dark Nebula, in Ophiuchus about 68,500 light-years away. This is M57, the Ring Nebula in Lyra, about 2,000 light-years from us. This is the Butterfly Nebula, shaped by gas jets from a dying star. This is the Crab Nebula, the remnant of a supernova explosion. This is the Kepler supernova, the last supernova in our galaxy observable with the naked eye. This is the DG supernova, about 7,500 light-years away and once seen by early astronomers. This is the Sagittarius Dwarf Elliptical Galaxy, a satellite galaxy in Aries. This is the Tarantula Nebula, a massive emission nebula within the Large Magellanic Cloud. This is the Barnard Galaxy, an irregular galaxy in Sagittarius about 1.6 million light-years from Earth. This is the Fireworks Galaxy, about 20 million light-years away in Cygnus. This is the Milky Way Galaxy, spanning about 100,000 light-years across, nearly the same age as the universe itself. This is the Hoag's Object, a nearly perfect ring of stars made of 800 million blue stars. This is the Cartwheel Galaxy, a lens-shaped galaxy in the constellation Sculptor, about 500 million light-years away. This is the Andromeda Galaxy, destined to collide with the Milky Way in about 4 billion years. This is IC 1101, the largest known galaxy in the observable universe. This is our local group, made up of more than 50 galaxies. This is the Virgo supercluster, home to over 2,000 galaxies. This is the Laniakea supercluster, containing more than 100,000 galaxies. This is the Sloan Great Wall, the most massive known structure in the observable universe. This is the observable universe, spanning up to 93 billion light-years, the limit of our current understanding. Scientists speculate that beyond this, there may be countless parallel universes. Yes, this is our universe, a place we can never escape. And when we step back and look, all the ambitions, all the glory, and all the pain we chase, compared to the scale of the cosmos, it all seems so tiny. So what does it all mean? Maybe after watching this, you've already found your answer. Are humans the only civilization in the entire universe? In 1950, physicist Enrico Fermi raised a question that still haunts scientists today. If aliens exist, where is everybody? This deceptively simple question revealed a staggering contradiction. The universe is unimaginably vast, yet we see no sign of intelligent life. This mystery is what we now call the Fermi paradox. Fermi believed Earth and humans are nothing special. We're just one civilization on a random rocky planet in the Milky Way. If life could appear here, shouldn't it also emerge elsewhere in the cosmos? So, why haven't we found any? In 1960, astronomer Frank Drake introduced the Drake equation, a formula to estimate the number of intelligent civilizations in our galaxy. Based on observations, the Milky Way contains 100 to 400 billion stars, most of which host planetary systems. Roughly 1 in every 4 systems likely has an Earth-like planet in the habitable zone. Even with conservative estimates, the galaxy could have over 10 million Earth-like worlds. Even if intelligent life is rare, there might still be 200,000 civilizations. At the very least, 800. So where are they? Even if they're all sending signals into space. The Milky Way is so large, it could take 1,000 years for any 2 civilizations to detect each other. And not all regions of the galaxy are habitable. The galactic center is chaotic, dense with stars, radiation, and a massive black hole. The outer edges risk losing stars to intergalactic space. The best zone for life? The Orion Arm, where our solar system happens to be. So those 800 civilizations? They may not be that far apart after all. Fermi also suggested that, with our current pace of technological growth, humanity could explore the entire galaxy in just 1 million years. But the universe is 13.8 billion years old. Surely some civilization should have done that by now. So why haven't we been visited? Ring Planet 3 theories attempt to answer this. Keycap 1 Cosmic isolation. Even if other civilizations exist, the speed of light is a hard limit. If an alien race is watching us from 65 million light-years away, they're seeing dinosaurs, not humans. By the time our signal reaches them, they might be long gone. In the vastness of space and time, every civilization might be doomed to miss each other. Keycap 2 were the first. Maybe we're the first intelligent civilization. The only one for now. Life might be so incredibly rare that it only happened once here. Keycap 3 The Dark Forest Theory, from the sci-fi novel The Three-Body Problem. The universe is a dark forest. Every civilization is a hunter, hiding in silence. Because if you reveal your location, you risk being destroyed by something stronger. Puzzle piece, so, which theory should we believe? In 1996, scientist Robin Hansen proposed the Great Filter, a series of 9 critical stages a civilization must pass to reach the stars. Form in a suitable star system. Develop self-replicating molecules, like RNA. Evolve single-celled life. Evolve complex cells, eukaryotes. Become multicellular. Develop sexual reproduction. Evolve intelligence. Reach a technological civilization. Achieve interstellar colonization. If a civilization fails any step, it may go extinct. Perhaps most of them die at step 9, before they ever leave their planet. Destroyed by nuclear war, climate collapse, asteroid impacts, or gamma-ray bursts. This is the harsh reality of the Great Filter. Exploding heads, so what should we do? If we find an advanced alien civilization someday, it means we might join them. But if we only find primitive life, never anything advanced, It may mean every intelligent species is eventually wiped out. That is the most terrifying possibility behind the Fermi paradox. If you're fascinated by the mysteries of the universe, like this video, subscribe, and we'll see you in the next one.